Hello there. Happy Friday. Um, Friday evening. Uh, this is our normally scheduled Friday evening stream. Okay, maybe not normally scheduled, but anyway, how are you all doing today? If you're watching this live, I'm just checking everything looks a-okay. Um, so yeah, let's get into it. Today I was going to cover a few topics. The main one is about um, transient astronomical phenomena, basically things that change in the sky. But it is more interesting than maybe it sounds. Also, I was looking at, I wanted to cover a couple of things before that. So, one thing that I've seen people talking about astronomically in the last few days was this parade of planets. And I think it's kind of it's kind of not as people would so people are theoretic so what is it? There are 6 planets that are going to be visible in the morning sky. Some people are calling it a parade of planets, but I think it's kind of overblown. It's basically, so of the 6 planets that are going to be in the morning sky starting around now, 2 of them are way too close to the sun, Mercury and Jupiter, and 2 of them are not naked eye visible, uh, Uranus and Neptune. And furthermore, they're not exactly lined up. They're kind of scattered over a 60-degree field of view. Let me show you. I looked it up because I was like, given how much people are talking about, or some people are talking about this, I thought, surely this must be something. But let's look at this. Let me bring up Stellarium. And so here is what the sky looks like tomorrow morning where I live at 6 a.m. And the sun rises around 6:45 or something. So it's already twilight at this point. And you can see like Jupiter is only 3 degrees above the horizon. It's barely visible. If it, assuming you have a completely flat horizon, if you don't, you're probably not going to see it. And this is a 43-degree field of view. So, like, the moon is way up here, but actually, I zoomed out too far. Let me. Saturn. Is Saturn up here? Yeah, look, Saturn is way over here. So, yeah, sure, there's 6 planets, but only 4 are naked eye and 2 really aren't. So it's really, I mean, 2 of those 4 really aren't. And so it's kind of, I think some people are going to be disappointed if they kind of followed that advice to go see the parade of planets in the morning. Now, that said, yeah, and so what else isn't visible? I'm not sure where this, anyway, I'm not sure where this even came from. Venus isn't in there. And it doesn't seem like that interesting. It would be really hard to get Neptune and to get all the, you wouldn't be able to see all of them at the same, I mean, in a photo. And anyhow, but what I find more interesting are conjunctions and occultations, which I'll get into a little later and explain that more. Also, I wanted to kind of discuss an update on the sun, especially our favorite sunspot group, AR3664. It has come around the sun now, but it is still fairly active. It has produced several X-class flares, and it did actually finally produce a coronal mass ejection, but it may or may not actually hit Earth. Even then, I don't think it's going to be anything as spectacular as the previous eruptions. This is spaceweather.com, which I've mentioned before. They said one of the reasons why it's so active is it's got kind of the magnetic fields are very kind of strong in that area and opposing, so it kind of causes these kind of major events. But so that's something to kind of keep an eye on the news for in the next few days as it continues to go across the sun's disk, in case it or some other sunspot group ends up producing something. So that is that on that. So now let's get to the main kind of the main topic, which is transient astronomical phenomena, or time domain astronomy, which is usually kind of it's usually defined for things outside of the solar system, but I'm going to kind of cast a wide net here and include a bunch of other things that I think, involve the sky and astronomical objects or phenomena. And I'll probably create another video on this topic and kind of go into more depth and like actually have a kind of a more produced video, because I think it's a topic that's of interest, and there's a lot of things in there for everybody, I think. It's nice to like look at galaxies and photograph galaxies and nebula, but there's a lot of things that go on in the sky that kind of where things change. And so basically I'm going to include anything changeable, unpredictable, and or unusual. And I'm not going to necessarily go over sufficiently long time frames. Things that we think of as fixed in the sky aren't. Like the stars move, and so stars that we currently see in tens of thousands of years won't be necessarily visible. Other ones will become visible. And a fun thing I always find is that on shorter, more human scales, human history scales, the North Star Polaris is not actually in a fixed location, because the whole Earth basically precesses like a top spinning. When you have a top and it kind of starts rotating around like the spinning axis and it's kind of rotating. Well, Earth does that. And so you can actually see, I actually did a little video of this. You can actually see this is actually this is in Stellarium looking straight up with Polaris kind of in the field of view. And I'm going to go backwards in time, all the way back to when the pyramids were built. So you can see over time, the Polaris actually ends up, like when the pyramids were built, Polaris was this star that was like 25 degrees away from the North Celestial Pole. And actually, the Milky Way, like if you go back like tens of thousands of years, the Milky Way, part of the Milky Way was actually really close to the North Celestial Pole. So that's kind of interesting. Like I'm not going to get into that part of things that change over very long periods of time. These are things that are maybe short-lived things that you can observe. And I'm going to focus mostly on things that you can actually observe with either a small telescope or binoculars or even a camera. So I'm going to start. This is going to kind of cover a whole bunch of different a whole bunch of ground, but we're going to start with Earth. It's where we keep our stuff. But we're going to start with, I'm just going to kind of talk about like, you know, close to home phenomena, which you may have already seen on the screen there. Aurora are kind of, I don't have any photos of them, but a lot of people saw them recently. Those are triggered by geomagnetic storms. So it kind of comes a source from outside of Earth. The sun ejects large coronal mass ejection. It hits Earth's magnetosphere, and it ionizes things in the upper atmosphere. I guess I kind of mention it because it's kind of even though it's in Earth's upper atmosphere, it doesn't have anything to do with the weather. It's kind of an external thing from Earth that kind of manifests itself in the atmosphere, which is kind of cool when you think about it, that basically the sun fires something at Earth and all these magnetic fields kind of absorb a lot of the energy, and the upper atmosphere absorbs it and produces this pretty light. Other things that we see from Earth, and I'm going to kind of go over a lot of these quickly because, a lot of us are familiar with these, are meteors, meteor showers. So meteor showers are kind of like believed to be, well, in some cases, they're the dust, the debris that's left in the orbit of a comet. And when that orbit intersects Earth, you get a meteor shower. Now, I don't know that all meteor showers are associated with comets, but some of them are. So we kind of, it's not a perfect thing, but they can kind of sometimes predict or get a guess if it's maybe going to be a stronger meteor shower based on how the comet behaved earlier in its orbit. So I don't have any photos of those, but, shooting stars and such. Now, other things that are in the sky that are kind of, they're not really cosmic things, but they're things in the sky outside of Earth's atmosphere, are satellites. And satellites are kind of, and I'm going to have, I'll link to an article where I kind of go over all these things if you want to read about them later. Satellites are kind of interesting. They're kind of a nuisance sometimes if you're taking a photo and the satellite goes through it. It's, the big mega constellations like Starlink, and there's going to be some other ones coming online at some point. They kind of interfere with photography, but modern astrophotography, you can kind of work around it, or you work around it. It's not a huge problem. But what I find interesting is some of the transient phenomena related to these that are unexpected. The first one is satellite flares, which, if you've never heard of them, basically satellites have, most satellites in Earth orbit have solar panels, probably just about 100% of them, almost 100%. And those solar panels are reflective. And you know how bright the sun can be if you see it reflected off a car windshield. Well, historically, this wasn't a problem so much, but starting in the 1990s, when one of the first constellations was orbited, was launched, the Iridium satellites, they started having these, I guess initially they didn't think it was going to be a problem, but it started getting to be a problem. And astrophotography wasn't kind of where it is today, where you can, you can take shorter exposures and kind of average out the satellite trails. The satellite flares, hold on a second, hold on. I just realized something. No? Weird. Oh. Okay. Sorry, I just noticed that I had turned off something unintentionally. Okay. My laptop was running on battery, and anyway. So satellite flares. The solar panels on these Iridium satellites were quite large, and The problem was the way their orbits were structured and that there were several of them. It became a recurring thing where the sun would reflect off these solar panels and would be visible from the ground. And it was surprisingly bright. The iridium flares could be much brighter than Venus, Jupiter. They sometimes were actually visible during daylight. I remember, and of course there was software and websites that could predict them. And I vaguely remember seeing one, and I think I saw it during the day, where you just suddenly see this like flare, this thing that's like a star kind of become visible. It kind of was a problem. And these things are still, it turns out, with like some of these satellites, like the Starlink satellites, their solar panels might not be as big as the Iridium satellites, but it's still something. I'll link to an article about it, but it's something that can be predicted and watched for. And I think even the International Space Station sometimes causes flares, which could be interesting, and it could be misleading. Like if you're outside at night and you see this flash of light in the sky, it's not clear that was just a very, high intensity reflection of sunlight off of a satellite. It just doesn't seem like something likely, but it's a problem. Wait, hold on. That's too bad. So you almost caught a shooting star, but no battery. That's always a drag. So on the topic of going kind of on satellites, one other thing that's kind of interesting is transits. And what's a transit? A transit is when a smaller astronomical object goes over a bigger object. There's another thing where a bigger object goes over a smaller object, which I'll get to a little later. But basically, sometimes satellites will transit the sun or the moon, and most satellites are too small, but bigger ones like the International Space Station, you can actually see them. And I've done a video about this before, but basically there's this transit finder website where you can plug in your location, and it'll tell you transits of when the International Space Station will cross over the sun or moon. And I use that. Let me see if I can play this without causing too much chaos here. And so this was a Google short I did about it. But you can see I took this with the Sea Star. That was the International Space Station crossing the sun. And the reason why the video was kind of a little janky was because I think I was shooting RAW, and so it wasn't doing like the full 20 frames a second. It was doing like 12 frames a second. So that is kind of, I think that's all I'm going to like talk about with, that's all I'm going to talk about with satellites and such. So now let's kind of move on to the, hold on, I'm just checking to see if I got anything. Cool. So next, the solar system objects. Now, there are no natural things that transit over the moon, because that would be kind of a problem. That would mean there would be something between Earth and moon. Like maybe it's possible with near-Earth asteroids, but I think that would kind of make me a bit nervous if that were something that were more regular. Now, in the case of sun transits, you only see sun transits you only see natural things transit the sun if they have an orbit inside of Earth's. So for planets, that would only be Mercury and Venus. Now, Venus transited the sun twice in the early 2000s. And the next time it happens won't be until for like another 90 years or so. Now, Mercury transits more frequently, but it's not frequent. The next time it transits the sun will be in the year 2032. But that's kind of interesting. It looks, I mean, I've seen photographs of it. Unfortunately, I missed the Venus transit, but it's kind of like, you know, it's a round planet crossing the sun. It kind of looks like a sunspot or something, but it's a planet. So that's something to kind of, and again, this is kind of a collection of things to watch or to look for that vary or are different, or basically the non-static things in the sky that are kind of unusual or rare or rapid and unexpected. And, you know, there are, I'll get to some things where people will spend a lot of time on just that little sub branch of things, because it is a topic that people research on their own, not necessarily like satellite transits, but some of these other things can be an area of research or study. But all of them are kind of approachable, and even with fairly modest hardware. So it's something to, you know, kind of mix things up. So now we talked about transits, now conjunctions. And this gets back to the parade of planets. Now, a conjunction is when two objects appear near each other in the sky. So what is near, it would be like, you know, maybe a few times, like maybe a few times the width of the moon away from each other, the objects, you know, a few degrees or less. I don't know if there's a strict cutoff for that, but I find, instead of having like all the planets kind of scattered across the sky, the conjunctions are, I think, more interesting, because you have two different planets that are at different distances that appear very close together in the sky. And for those who may or may not remember it, back in 2020, December 2020, this is Saturn and this is Jupiter. They got pretty close to each other. I mean, just a fraction of a degree apart. And a lot of people took much better photos than I took. This was just with a 600 millimeter lens that I had, basically the same lens that I've used for some of my solar eclipse photos. But the conjunctions are really more interesting. And in August of this year, there will be a conjunction between Mars and Jupiter, and they will be pretty close to each other. This will be, and it's going to be the best conjunction this year. I'll leave a link in the description. Basically, the article that I'm going to link to will have all of that information. But if I cut back to Stellarium, hold on a second here. So it's going to be, let's look for Mars. And, oops, no emoji. So let's look for Mars. Or is it Saturn? No, is it in the evening sky or morning sky? Okay. I'll be in the, so let's, which one is it? Let's see. It is, oh, sorry, Jupiter. Jupiter. Okay, here we go. So if we look in, look at how close Mars and Jupiter will be. And in the C star, for the C star, which has a fairly not the tightest field of view, but it's a lot tighter than like most telephoto lenses. You can see both will be like half a degree, less than half a degree apart from each other. I think it's like 0.18 degrees away from each other. And that is is it in the morning of the 14th? It's around August 14th. Oops, it's below the horizon at that point. So the morning of the 15th. Oops, and I've overshot. Let's look on the 14th. Yeah, and the 14th as well. So the 14th and 15th, right around that time, the two will be like really close to each other. So that's something to, I think, watch for rather than the parade of planets. And like I said, I'll include a list of other conjunctions this year, but that one between Jupiter and Mars will be the most spectacular one. And actually, just going back to that, it's what's really cool if you look at this. Like, here's Mars, and this is where these are two of Jupiter's moons. So if you get like a nice tight photo in there, like Jupiter's moons won't be that much, like Mars won't be that much further from Jupiter than Jupiter's moons are. I mean, from apparent distance. In reality, it's like hundreds of millions of miles away. But still, kind of something interesting. Yeah, so now we talked about little things passing over bigger things, transits. Now, what happens when larger things go over smaller things? Those are occultations. And technically, I guess a total solar eclipse is an occultation because the moon, it has an apparent size slightly larger than the sun. But usually, and usually the main suspect is the moon. The moon will go over planets. It happens several times a year. And for example, on September 17th this year, the moon will go over Saturn, but it's only going to be visible from the western part of the US. And yeah, in some other places, but further west. But like, for example, in Houston, I looked it up, and basically the moon sets like just like less than an hour before it goes over Saturn. But that's something that could be interesting. And if you look online, you'll see photos of what it looks like, where you see the tiny little Saturn and then the moon just goes right over it. Now, sometimes you have a more rare thing where a planet will go over a fairly bright star. And the next time a bright star is covered by a planet is in 2044, when Venus goes over Regulus. And kind of a fun thing about that is Uranus's moon rings were discovered by when the planet went over a star, a distant star. They saw like the brightness dip before the planet kind of went over the star. So that's kind of an interesting thing. And then I have some other things like comets, like those kind of appear, and usually they aren't as spectacular as one would like, but they're, you know, with modern cameras you can image them, and they're cool. And then sometimes you end up with something unusual where like in the 90s, the comet Levy-Shoemaker broke up and collided with Jupiter. And there were some space probes that were able, and the Hubble Space Telescope were able to kind of image the aftermath on Jupiter. And I don't think any amateurs, maybe some amateurs were able to image it. But I think today, with today's techniques and lucky imaging and some of the, you know, electronic, the astrophotography, it would be something that you could actually capture. Now, the trick is, like, in the case of that comet, it left some pretty big marks in Jupiter's atmosphere that were there for days or longer, weeks. Now, there's shorter duration things when, say, a little meteoroid hits the moon and it will flash, it'll cause a flash. Well, there's one of the pieces of software that people use for planetary imaging is fire capture. And fire capture has a plugin that looks for flashes. It looks for these transient flashes of light if you have it pointed at the moon. And I think this is kind of interesting. That software has been used. Was it on this one? No. Oh yeah, this software has been used to detect 160 impacts on the moon. Now they're small, but I want to say some of them they've been able to detect small little craters after the fact. But it's something interesting that a hobbyist observer could use fire capture with an astronomy camera and a telescope and point it at the moon, and you might end up seeing something. And they do say that they believe it should pick up things that hit other planets. So that could be kind of an interesting kind of avenue of exploration. I guess so. So those are kind of transients where something like something drastic happened. Now there's variable transients. So, or things that vary. So you have like solar weather. You can look at sunspots. You can look at the prominences if you have the right kind of telescope. So those are kind of interesting, and that's an area that you can see a lot from. I think a lot of people have picked up solar telescopes since recently, because I've seen a few YouTube videos from some people recently that I hadn't seen solar videos about until fairly recently. So, I mean, I picked up one last year too, so it's I can't really say anything. So then the final thing, we've talked about things in the solar system. We talked about things transiting, occulting, conjunctions, solar weather, auroras, satellite stuff. So now let's talk about things outside of the solar system. So first, variable stars. The first thing I'm going to talk about is variable stars. Now, some of them are regular and irregular, and then some are cataclysmic variables, like that T Coronae Borealis, the blaze star. That's a cataclysmic variable. But there's a lot of stars in the sky that are variable, that are of reasonable brightness, and there's variable star observing kind of organization, scientific amateur organization. And some of the stars they're variable in a detectable, they're detectable. Like you can take photos over a period of time and you can see a particular star in the field getting brighter and dimmer by maybe not drastically, maybe not as drastic as the T Coronae Borealis nova, but something you can still watch or see. And along those lines, you have kind of recurrent, and the reason these stars vary, there's varying reasons. Some of them include the star just kind of has some kind of oscillation. It might be a binary star system where they kind of interact, or because of their orbits around each other, one maybe occults the other and things dim when that happens. Like there's several different reasons. I've seen ones where, or I've heard of ones where I think like there's one big star and then like a white dwarf, and then the white dwarf is pulling off matter, and then periodically it flares up, pulls off matter from the red giant. So there's many different reasons, but there's a large number of variable stars that you can take photos of and image. Now, if you want something that is like a lot more drastic in as far as suddenly brightening and staying much brighter, there's supernovas. And it's pretty easy to take a photo of a supernova. There haven't been any in our galaxy in a while, but there's always ones in other galaxies, like all the time. And there's in the article, or the post I made, it has a list of all the of a website, or one of the websites that has a list of all the current bright supernovas. And this was an example of one I took a few months ago. This one is this star right here is not normally there. It's it was like 14th magnitude or brighter, and this was NGC 4216. I've talked about it in some other streams, and that one was kind of interesting. That galaxy was I think it was like 50 or 60 million light years away. And again, this was taken, it was like 3 hours worth of exposures, but taken with my C star. So it wasn't like anything crazy instrument wise. Like, so that's kind of an interesting thing, seeing kind of an exploding star. Now the final thing that I wanted to talk about are galaxies. And galaxies can vary in brightness, active galaxies. And quasars are a subset of active galaxies. Quasars are kind of, they're intrinsically some of the brightest things in the universe. And they're powered by, or believed to be powered by, supermassive black holes that could be billions of times more massive than our sun, and they're consuming a vast amount of matter, and they're producing massive eruptions of electromagnetic radiation across the spectrum, like radio waves and gamma rays and X-rays. And some of these, they have relativistic jets where they're firing matter out at a fraction of the speed of light. And sometimes if the jet is pointing towards us, because it's kind of like a fire hose, but on a cosmic scale, because of magnetic fields, that jet of matter might kind of wobble. And so it actually will vary. So you're talking about something that's like as bright as hundreds of billions of stars that might vary over short periods of time, that with amateur equipment, if you're taking photos of it, you can capture, you can see that it varies over time. It might not be a drastic amount, but still it could be like half, it could be like half a magnitude or so, but nothing like, but still, when you think about the amount of energy that's being kind of pumped out, the fact that it might vary over days that much is kind of, or even if it's over weeks, it's still kind of spectacular to think about it. Now, I haven't actually imaged, or I haven't measured the variation of these, any quasars, but you can definitely image them. So here is, and this is kind of the last thing. and this was what I had in the thumbnail. This little dot here that I'm pointing at, which I hope shows up on YouTube, but it's there. It's kind of, you have this kind of hexagonal pattern, and there's kind of an offset star right here. Well, that star is PG 1718 plus 481. That's the catalog it came from, and it's 8.1 billion light years away. And I took that photo. It was an hour photo with my C-Star in Houston. So there's a good chance if you have a telescope, at least as big as the C-Star, and you're in better and less light polluted area, which you probably are, you can get that photo more easily. And if you get a longer photo, you should be able to take a series of them and might be able to see it vary. But the light from that star, from that quasar that my telescope captured, was emitted like over 3 billion years before the solar system was formed, which I think on that note, I'm going to leave it. But that's going to be a topic for another day. Some of the quasars will be a topic for another day. But yeah, like I said at the beginning, I'm going to probably make a longer version of this at some point, but it'll be a produced video, so it should be a little bit tight. Because I feel like it's a big topic and a lot of people will be interested in some different aspects of it, or I might chop it up into multiple videos just covering one topic. And that's all I have right now. So thanks for watching. If you're watching this afterwards, like and subscribe. And I will leave it at that, I think. Let me just double check that there's that the YouTube messages didn't mess up and I missed something. But nope. Yep. Thanks for tuning in, and we'll see you in the next video.